Hi everyone, welcome to Vidyalakshmi CBSE YouTube channel. This is chemistry faculty from this school. My name is T. Naresh Reddy. I am going to discuss in today's class about one of the important chapter in the physical chemistry of our plus 2, that is surface chemistry. Okay. So, in this class, what are the concepts we are going to discuss? Let us see once. What is a surface chemistry and what are the processes we are going to that is what are the process taking place in surface chemistry, okay, and what do we call those, and how that a surface processes are taking place simultaneously as a spontaneous one, okay. So, those concepts let us discuss in today's class, okay. So, shall we start our class? Yes, let us go. So, let us say what is surface chemistry means. Surface chemistry is a branch of science which deals about the reactions that takes place on the surface or boundary or interface. Okay, for example, what is the meaning of that means? Here I am taking my pen. When I am writing on this board, the ink is ink is occupying on the surface of this blackboard, right? Okay. So, if any process which are taking place on the surface, those processes we are discussing in this surface chemistry phenomena. Clear? But here, since we are going to discuss about the surface chemistry, reactions which are taking place on the surface, those we discuss here. Okay. So, here deals about the reactions that takes place on the surface or boundary or interface. Now, here surface interface is a few molecules thickness. Okay. For example, here I am taking, this is, let us take a substance where some chemical reaction is taking place. This we call as a charcoal, right. So, here in this charcoal, let us pass some hydrogen gas and nitrogen gas. Okay. So, when these gases, if you are passing on to this charcoal, they will come and occupy on the surface of this charcoal. Clear? Since these two gases came and occupy on this, so that those two gases are occupying on the surface of this charcoal. Clear? So, here where up to what part of this charcoal we have to consider as a surface and up to what part we have to consider as a bulk means. Let us take, this is the shape of the charcoal, and this up to these few parts we call as a surface. We call that as surface. Then remaining part I am taking, the remaining part of this charcoal or substance whatever we are taking, that we call as bulk. So, here those hydrogen and nitrogen gases should come and occupy on the surface only, they should not enter into bulk of this charcoal or object or substance. Okay. So, here no interface for gases. We can express the surfaces for the solid and liquids, but we can't express for this surface to the gases. What is the reason for that means? If I am taking a gas, okay, if we are mixing any two gases, they will completely mix with each other. They will completely mix with each other. Due to that complete mixing of the two gases, we can't express the surface for a gas. So, that in surface chemistry, we have to take either solid or liquid substances only, which are providing the surface to take part in a chemical reaction. Okay. Now, so this is about what is surface chemistry and for what particles only, that means for what substances only we have to consider surface, and up to what depth of that substance we have to consider as a surface. Okay. Now, let us see where in our daily example we can say these surface phenomena. Okay. For example, if we say falling of a dust on our room, whatever the objects present in our room, on that some dust will fall. That dust occupy on the surface of those objects. That is also a surface phenomena, right? So like that, few chemical reactions are taking place on the surface. What we are seeing in our daily life, those are corrosion process, electrode process, heterogeneous catalysis, dissolution and crystallization process. Okay. So let us see here what is how this corrosion is a surface phenomena. So if we say this is an iron rod which is rusted here, I am taking a iron rod which is rusted here. Okay, if we see that rusted iron, that formed rust which is nothing but ferric oxide Fe2O3 XH2O, hydrated ferric oxide, that is the chemical formula of rust, that is appearing on surface of this iron rod. Okay, since here on the surface of this iron rod rust is appearing, we are calling that corrosion as a surface phenomena. In electrode process also, what is happening in electrode processes means, I am taking two solutions in two beakers. After that, I am dipping two electrodes, that is cathode and anode. Here I am taking those two electrodes as zinc and copper. Okay, after that, if you are connecting these two electrodes, that is zinc and copper electrodes, to the if you are connecting to the external circuit, if you are passing the current, then some reaction takes place. During that reaction, the blue color of this copper sulfate solution decreases. Blue color of that copper sulfate solution decreases. Here I am taking this one is a zinc sulfate solution and this one is copper sulfate solution. Okay, this copper sulfate solution is a blue color. If you are passing current through these two electrodes, that is through bulb, then some reaction takes place between these two solutions. Due to that reaction, blue color of the copper sulfate decreases. What is that reaction taking place here means, zinc is participating in oxidation reaction and copper is participating in reduction reaction. How means the zinc rod is liberating two electrons. So those two electrons are transferring to copper rod. So those two electrons which are now entering into the copper rod, they are accepted by the Cu plus 2 ions present in this copper sulfate solution. So when Cu plus 2 ion, which is responsible for the blue color, accept two electrons, it converts to the copper metal. That formed copper metal is depositing on this copper electrode. It is depositing on copper electrode. That process we are calling as electrode process. Okay. So here, since copper metal is deposited on the surface, this electrode process is also one of the example of surface chemistry. Okay. And in heterogeneous catalysis, what is happening means, let us take, this is a catalyst. Catalyst is a substance which is increasing the speed of a reaction. Okay. And let us take these white balls and red balls, I am taking as a reactant molecules. Okay. These reactant molecules, they are occupying on the surface of this catalyst, so that those will participate in a chemical reaction. Since chemical reaction is taking place on the surface, if you are seeing carefully here, that red ball colors, white ball colors, okay, those are the reactant molecules, those are participating in the chemical reaction on the surface of this catalyst only. So we are calling this as surface process, and since chemical reaction is taking place, we are calling that as a surface chemistry. Okay, so that electro-heterogeneous catalysis is also one of the example of surface phenomena, and dissolution is also example of surface phenomena. On the dissolution process, we are dissolving some substances into a solvent. During the dissolving of substance in a solvent molecule, the solute particles are in contact with the surface of solvent molecules. So that dissolution is also example for the surface phenomena, and crystallization process is also example for surface phenomena. Okay, so these are the few examples where we are seeing in our daily life. Okay, now let us see what is the how do we get a clean surface. What is the need to produce a clean surface of the substance to participate in a surface reactions? So let us take, for example, here I am taking, this is a solid substance which is providing the surface. If I am keeping, let us take, for example, this is a substance which is providing a surface. If I am keeping on this room, then whatever the gases which are present in this atmosphere will come and occupy on this surface, so that this surface is not in free state to participate in a chemical reaction. So before going to take a substance which is providing a surface in a chemical reaction, we should maintain that surface substance as in clean condition, means nothing, gases or anything should not occupy on the surface. If anything is occupying, that surface is not in free state, so that capacity to participate in a chemical reaction decrease if anything is occupied on this surface. So to prevent that, means to provide free surface for a substance, we always store that substance in a vacuum where there is no gases present. Okay. If we maintain the pressure exerted by a gases as like this, that is 10 power minus 8 into 10 power minus 9, that is 10 power minus 8 to 10 power minus 9 pascals, where pressure is very less. 10 power minus 8 means it is a very less value, so that the pressures present in that environment also, that is the gases present in that environment also less. Okay. So that at this pressure, if we maintain in any environment, that environment we call as vacuum, where pressure of the gases is very less. On that vacuum, since pressure of the gases is less, pressure that is gases also less, that is amount of the gases less on that environment. So that always we have to keep the substance which is providing the surface in a reaction in vacuum or in special condition environment. Okay. So that no gases are there, so that surface is now in free state which is readily participate in a reaction. That is the importance, or that is the main concept, to provide free surface area to participate chemical reaction by that surface substance more. Okay. So how do we provide that free surface? Means by putting that substance in a vacuum. Clear? Right. Now let us see about what is which type of processes we can get. Which type of processes we can get in this surface process, means adsorption, absorption. Two types of processes are there. Okay. Let us say between adsorption and absorption, which one only we call as a surface process and which one we call as bulk process. So let us see once again. So here I am taking, this is a substance which is providing, I am taking, this is a substance which is providing surface. This is a substance which is providing surface. Okay. Now the particles, these are the particles which are coming and occupy on this surface, which are coming and occupy on this surface. The coming and occupying we are calling as accumulation. So the accumulation of these substance on the surface of another substance we are calling as adsorption process. We are calling that process as adsorption process. So here accumulation means the particles are coming and occupying on this surface. If you are putting, if whatever the objects we are taking in this class or in this environment, some dust particle come and occupy on the surface, right? So here also that coming and occupying we are calling as a accumulation. That accumulation of a molecules of the particles, okay, or molecules of a substance on the surface of another one we are calling as adsorption process. Here which type of particles may come and occupy and which type of particles or molecules provide surface. If we take that, the particles or molecules may be solid or liquid or gas which are coming and occupying on the surface. The molecules which are coming and occupy on the surface, they may be either solid or liquid or gas, and this substance which is providing, the substance which is providing surface is either a solid or liquid, but we are not taking here gas which is a substance providing surface, that we not take, because we already discussed here that gases, for gases we do not express any surface. That is why for gas molecules surface substance we are not taking. Only for solid and liquid provide surface. On that liquid or solid, if any molecules, any type of molecules come and occupying, then we call that as adsorption process. Clear? And in this sense, these molecules are coming and occupying only on the surface. We are calling this one as a surface phenomena, means adsorption is a surface phenomena. If more number of molecules are occupying on this surface, then concentration of that surface increase. If less number of surface molecules are occupying on the surface, then concentration of that surface decrease. So the concentration of the surface mainly depends on how many molecules are occupying on surface of the solid. Clear? So that concentration increases only on surface. When the number of molecules increases on the surface, then concentration of the surface increase. Okay? So the concentration increases only on surface. It is not enter into the bulk. So here in this part only we are taking as a surface. The remaining part we can call as bulk. This we call as bulk. But these molecules are not entering into the bulk, they are occupying only on the surface. Clear? So here also if you are taking any plastic pipe, if you are dipping on the water and if you are taking again back, then water droplets, they will stick on the surface of that plastic pipe, right? So that process is also example for surface phenomena or adsorption. So that adsorption is a surface phenomena only. Clear? Now let us see about what is absorption and what is the difference between adsorption and absorption. Okay, so here if we see here, so here we already discussed this point that this is the substance which is providing a surface. Here also this is the substance which is providing surface. Clear? In that adsorption process, that is we already discussed that these are molecules which are coming and occupying on the surface, we are calling that process as adsorption. We are calling that process as adsorption. Now here if we take, in this case what is happening here, apart from entering into the surface of this substance, after that they are enter into the bulk. They are enter into the bulk. This one we call as a bulk, right? So since these molecules are enter into the bulk, then we call this process as a bulk phenomena. Since those molecules are enter into the bulk, we are calling this as a bulk phenomena. If any process is taking place as a bulk phenomena where molecules are enter into the bulk of another substance, such type of process we are calling as absorption process. Okay, so that accumulation of substances into the bulk of a solid or liquid is called absorption. Okay, adsorption is taking place on the surface only, but absorption is taking place inside of substance. So, inside of substance is nothing but bulk, so that this absorption is a bulk phenomena, whereas adsorption is surface phenomena. Okay. If more number of molecules are entering into the bulk, then what about the concentration of that bulk? Increases. So, that concentration increases in bulk. Concentration is nothing but the number of molecules present in a unit volume. So, in this unit volume, if more number of molecules are occupying, then concentration increases. Okay, if number of less molecules are occupying, then concentration decreases. Is it clear? But everything taking place in bulk only, so that concentration increases in bulk only in absorption process, whereas in adsorption concentration increases on the surface. So, these are the differences between adsorption and absorption. So, adsorption is a surface phenomena where concentration increases, on surface, and absorption is a bulk phenomena where concentration increases on bulk. Clear? So, I think you know what is the clear difference between absorption and adsorption, right? Okay, now let us see about, so let us take, if you are dipping the sponge in a water, the water molecules are enter inside of the sponge. Since water molecules are enter inside of the sponge, we are calling that as absorption process. Okay, even if you are dipping any biscuit in a milk or in tea, that is also absorption process, because the liquid particles present in the tea or milk enter into the bulk of biscuits, right? Okay, so that is also we can take as an example for absorption. Now let us see where we can see this adsorption process in our daily life. Clear? So, falling of dust particles on any object in our environment is example for adsorption. Okay. If we want to control the humidity in our classroom or in our environment, that is also example for adsorption. How do we control the humidity in our classroom means? We can do in two ways. One is by putting, one way is by putting this silica gel in our environment. In our room, if we want to control the moisture, then we have to put silica gel in our room. Okay. So, when we are keeping the silica gel in our room, then the moisture particles, nothing but water particles which are present in room, they come and occupy on the surface of this silica gel, on the surface of silica gel. Okay. During the transportation of some important items, we will see that some packets are kept inside the boxes. Those packets is nothing but silica gel packets. Why we have to use that means, if any moisture is there during the packing of that box, that moisture will be adsorbed by the silica gel, so that that item won't damage. Clear? So, here that is one of the example for adsorption process where we are seeing in our surroundings. Okay. But if the same process means to control the humidity in our environment, in place of silica gel, if you are using calcium carbide packets, if you are using calcium carbide, anhydride calcium carbide packets, that anhydride calcium carbide absorb the water molecules, means inside calcium carbide molecules, that water molecules enter, which are present in the environment. So, that thus controlling of the humidity by using the anhydrous calcium carbide is an example of absorption. On that calcium carbide size swell, because water molecules are enter into the inside of calcium carbide. So, the calcium carbide size swell. But here swell of the silica gel not increase because just they are coming and occupy on the surface only. So, this is an example for adsorption. This is example for adsorption and this is example for absorption where we are seeing in our daily life. And if we take another example for the adsorption, conversion of organic dye means colored substance like methylene blue to colorless solution by passing through charcoal. This is the colored solution I am taking. Okay. If we are putting charcoal inside this color solution, then after some time it converts to the colorless solution. Why means here the colored particles which are responsible in this solution, they are coming and occupy on the surface of charcoal. If we are removing the charcoal from that, then colorless solution only we can get. Since these colored particles come and occupy on the surface, that is also example for adsorption process. Okay. And raw sugar, where sugar we are getting in sugar industry, that raw sugar is not a colorless solution, it is a colored solution. That colored color is coming to that raw sugar is due to the presence of impurities. So, to convert that raw sugar to our pure sugar means to convert that impure sugar to the pure sugar, we have to remove those impurity substances which causing the color to that raw sugar. By keeping that raw sugar in animal charcoal, if you are passing that raw sugar solution through the animal charcoal, like this, then that animal charcoal absorb color particles or impure particles. So, that whatever the solution we are getting, that is our colorless pure sugar molecule. This also mainly using in sugar industry. Based on the adsorption surface phenomena, we are converting our impure sugar to pure sugar. Clear? And if you take another example, controlling of humidity, just now we discussed by using silica gel. On that silica gel, the moisture is adsorbed. That is, water droplets are adsorbed. These are the few examples where we are seeing in our daily life. That is conversion of the color solution to the colorless solution and conversion of raw sugar to the pure sugar by passing on to the animal charcoal and by controlling of humidity present in the environment, okay, and decreasing of the pressure present in our environment. If more air is present in our environment, then the pressure caused by that air also more. If we want to decrease the pressure which is exerted by that gases, then we have to arrange as animal charcoal or silica gel. If you are keeping in environment, then the air particles come and occupy on that surface of the charcoal, so that pressure of that environment decreases. So, to decrease the pressure of the gases, we have to pass those gases onto the charcoal. That is also an example for adsorption process. Okay. Now, let us see what are the different examples in our daily life we are seeing. One example we already discussed, that is dipping of sponge in water. Another example is controlling of humidity using calcium carbide, anhydrous calcium carbide. It is a powder, white powder. Okay. If we are keeping in an environment, then size of that calcium carbide increase due to absorption process. Clear? And another example is dipping of the chalk piece in colored ink. If you are dipping the chalk piece in the colored ink, after that if you are removing that chalk piece and if you are breaking, then if you see that colored particles, that colored ink particles are occupying on the surface of chalk piece only, but the water which is present in the ink enter inside of the chalk piece. So, that in these two processes are taking place. One is ink particle occupying on the surface and colored water molecules are enter into the surface, means adsorption and absorption takes place. So, this is the best example for adsorption as well as absorption. Okay. So, here now we discussed about what is adsorption and what is absorption, what is the difference between those. In some processes like dipping of the ink in that is dipping of the chalk paste in colored ink. In these type of processes, so in this process, if we take adsorption as well as absorption, both are taking place. If adsorption and absorption both are taking place, then we call that as sorption process. We call it as sorption process. So, this is best example for sorption, where adsorption and absorption is simultaneously taking place, right. Now, let us see about what is adsorbate, adsorbent, sorption and desorption. Just now we discussed what is the meaning of sorption. Sorption is nothing but the process where adsorption and absorption both are taking place simultaneously. Okay. After formation of the products in a chemical reaction, if we want to remove the formed products from this substance surface, then that process we are calling as desorption. We have to do the desorption of formed product from the surface. Okay. So, in desorption we are removing the substance which is occupying on the surface. The substance which is occupying on the surface we are calling as adsorbate, and the substance which is providing the surface we are calling as adsorbent. Okay. So, in this example, if we take colored ink particles are occupying on the surface, so that colored ink particles are adsorbate. Okay. And the chalk paste is providing the surface. The chalk paste we call as adsorbent. So, in this example, chalk paste is an example of adsorbent, and colored ink particles, colored ink, that acting as a adsorbate. If we want to remove that colored particle from the chalk paste, means we have to remove adsorbate from the adsorbent, then such process we are calling as desorption. Okay. After removing, if adsorption and absorption simultaneously takes place, then we call that as sorption process. Okay. So, this is about what is adsorption, what is absorption, what is the differences between this adsorption and absorption, which one is a bulk phenomena and which one is a surface phenomena. Okay. And what is adsorbent and what is adsorbate. This adsorption process we are discussing only in surface chemistry. Absorption we not discuss, because absorption is taking place in the bulk. Surface chemistry means the process which takes place only on the surface, but not in bulk, right. So, that this adsorbate, adsorbent and those terms we have to use in surface chemistry. So, adsorption process only we discuss, absorption we not discuss. Okay. So, that in next class, that is in next video, we will see whether that adsorption process is spontaneous or not. If you are dipping that chalk paste into the colored ink, then automatically colored ink particles are adsorbed on the chalk paste and water molecules are entered into the bulk. Automatically takes place. We can't do that. Those processes are spontaneous processes. Okay. So, here why adsorption is taking place spontaneously, that we will see in the next video. Okay. I hope you will understand this, that is, you understand this concept very well. Okay. So, if you understand, then please like, share and comment on this, so that I will try to provide more videos to you. Okay. So, see you to all in another video.